Then our next topic is a closed pair and convex hull problem. It is a two-dimensional versions of the closed pair problems, and the convex hull problems can be solved by the brute force algorithm in theta into n squared and big O of n cube time. The divide and conquer technique you provide the sophisticated and asymptotically more efficient algorithm to solve this problem. The closed pair problems let be a set of n greater than 1 points in the Cartesian place. The points are ordered in non-decreasing order of the x-coordinate. It will also be the convenient to have the points to stored by the merge sort in the separate in list in the non-decreasing order of the y-coordinate and denote such as a list of by q. If 2 less than or n less than or 3, the problem can be solved by the obvious the brute force algorithm. If n greater than 3, uh, we can divide the point into two subsets of p of l and p of r of n divided by 2 and n divided by 2 points. It is the respectively by the drawing the vertical line through the median of m of their x coordinates the sum n divided by 2 points. The lie to the left of r the on the line itself and n divided by 2 points lie to the right of or on the line. Then we have solved the closed pair problem to recursively subsets of p of L and P of R. Let D1 and DL and D are the smallest distance between the pairs of the points in P of L and P of R. It's respectively the let D equal to minimum DL into DL comma DR. For the algorithm of efficient um, closed pair of p comma q, to solve the closed pair the problem by the divide and conquer the input value an array of p of n greater than 2 points in the Cartesian plane sorted in non-decreasing order of the x coordinates and an array of q of the same points stored in the non-decreasing order of the y coordinates. The output of the output of the distance between the closed pair of the points if n uh, if n less than or 3. The return the minimal distance found by the brute force algorithm. Else the copy of first n divided by 2 points of P2 array PL, the copy of same n by 2 points from Q2 array QL, the copy of remaining n by 2 points of P2 array PR, the copy of same n divided by 2 points from Q2 array QR. If the DL tends to efficient closed pair of PL, QL, the DR tends to efficient closed pair of PR, QR. The T tends to minimum DL, DR to M tends to P of n divided by 2 minus 1 into X. The copy of the all points of Q for which X minus M less than D into array of capital S of 0, num minus 1. The D minimum SQ tends to D squared. For I tends to 0 to num minus 2 do K tends to I plus 1. Then while K less than or num minus 1 and S of K into Y minus S of I into Y whole square to less than D minimum SQ. q. Then sq to k tends to k plus 1. Return squared the d minimum of square. The algorithm spend the linear time both of dividing the problem into two problems of half the size and combining the obtain the solution. Therefore, assume as the useful that n is a power of 2. We have the following the recurrence for the running time of the algorithm. T of n equal to 2t into n divided by 2 plus m of n, where n m of n belongs to theta of n. To applying the master theorem of with a equal to 2, b equal to 2 and d equal to 1, we get the t of n belongs to theta of n log of n.